So I'm Chris Ogayon, and I will be reporting on Chapter 10, Architecting Digital Products and Services. So this is one of the chapters from the book 2021, Architecting the Digital Transformation, Digital Business, Technology Decision Support, Management by Alfred Zimmerman, Rainer Schmidt, Lakmi C. Jain. So for this chapter, I'll go through the following topics: the digital transformation, digital products and services, the principles of service dominant design, value-oriented architecture, the digital enterprise architecture, and I'll close it with the author's conclusion. So first, digitalization. So digitalization defines the process of digital transformation, which is promoted by important technology trends. So technology trends such as Internet of Things, IoT, AI or artificial intelligence, cloud computing, edge and fog computing, services computing, big data, mobile systems, and even social networks. So the author's goal in this chapter is to extend previous quite static approaches of enterprise architecture to fit for a flexible and adaptive digitalization of intelligent products and services. And their aim really in this chapter is to answer the research question, the fundamental research question of how can a value-oriented digital architecture for digital products and services be modeled to support the open world integration and management for a huge amount of dynamically growing microgranular intelligent systems and services. So for the research method, they used the following. Number one, set the fundamental architectural context of or for digital transformation, introducing digital products and services. Step number two, integrate fundamental perspectives and principles of the service dominant logic for architecting digital products and services. Number three, present the digital modeling approach for systematically defining value-oriented digital products and services. And lastly, number four, conclude the research findings, even mentioning the future work. So let's proceed with the first topic first, digital transformation. So there are four stages of digitization. For years, we have been experiencing hype about digitalization, in which the terms digitalization, digitization, and digital transformation. So these are often confusingly used, but there are actually differences, or there are main differences between those terminologies. So in the four stages of digitization, the first one, substitution. So this is analog media replaced by digital media. So this is really what we refer to when we say digitization. Augmentation. So this is digitized information consists of a combination of basic information and complemented by functional improvements. So for example, the addition of menus. Modification, so this is where you'll find functional extensions, which enable significant transformations of processing. So this is where process automation fall. And then lastly, the redefinition. So this enables new digital perspectives. So for example, through digital platforms and ecosystems. So this is also a table of the four stages of digitization. So the substitution. So one example here is the scientific paper as PDF file. For the augmentation, the example now is the enhanced version of the PDF file with direct connectors to processes and tools. For the modification, the paper submission now automatically triggers the subsequent review process. So remember the process automation. So that's modification. And then number four, redefinition. So this is now the digital platform, an ecosystem of living scientific conferences, journals, and other assets with co-creating people and intelligent services. So digitization and digitalization is about digital technology, whereas digital transformation is about the changing role of digital customers and the digital change process. So we digitize information, we digitalize processes and roles for extended platform-based business operation, and we digitally transform the business by promoting a digital strategy, customer-centric and value-oriented digital business models, and architecture-driven digital change. All right, so the five strategic domains that define the focus of a digital transformation. So this includes customers, competition, data, innovation, and value. For customers, some of the most important strategical change of customers in a digital business include customers as dynamic network, two-way communication for co-creation, customers are key influencers, marketing to inspire purchase and loyalty, reciprocal value flows, and economies of value. For competition, strategic changes also affect competitors, as competition across fluid industries, blurred differentiation between partners and competitors. Competitors cooperate in key areas or competition. Key assets reside in outside networks, platforms, and ecosystems with partners who exchange value, and winner takes all due to network effects. And for data, the strategic perspective on data in digital business can be described as data is generated and processed in real time. Data provides valuable information. Unstructured data is increasingly processable and valuable. Value of data results from connected data across silos, and data is a key asset for value creation. And for innovation, normally digital innovation is promoted by the following: decision based on testing and validating. Testing of ideas is cheap and easy. Experiments are conducted constantly by everyone. Challenge of innovation is to solve the right problem. Early and cheaply failures. Focus on minimum viable, so the minimum viable product. And prototype and fast iterations. So, say for instance, the practice of agile. And for value, the improved digital value perspective results from first, a value proposition defined by changing customer needs, uncover the next opportunity for customer value, evolve before you must to stay ahead, judge change by how it could create your next business, and stay always active and not looking for complacency. So let's go ahead and talk about the digital products and services. So the digital transformation, this is the current dominant type of business transformation, having IT both as a technology enabler and a strategic driver. So in the beginning, digitization was primarily considered a technical term. So thus, a number of technologies is often associated with digitization. So these technologies normally include the cloud computing, big data, social software, the Internet of Things, deep learning or machine learning. However, according to the authors, new ways of interaction with the customer are enabled by combining a product consisting of hardware and software with cloud provider services. And based on the current research, research also suggests that different customers will use different devices for different use cases, enabling new ways of triggering an interaction with business processes. So I think one example is one example of a hybrid value creation for digital products is the Amazon Alexa. So the Amazon Alexa consists of a physical device with microphone and a speaker. So you have your device, your physical hardware, and then within the device, you have an application running, and services called Alexa skills also exists within that technology. So the set of Alexa skills is dynamic, and this can be tailored to the customer's requirements during runtime. Digitized products and services support the co-creation of value together with a customer and other stakeholders in different ways. So primarily, internet connection of the digitized product allows to collect permanently data on the usage of the product. So the permanent feedback to the provider. And data provided by a large number of digitized products are able to provide new insights. So if you're familiar with telemetry data, um, typically our modern devices, our modern gadgets have this capability wherein telemetry data is collected from the device or from the gadget, and that's sent or submitted to the vendor. So the vendor now gets new insight, um, and these insights can range from, say, existing issues with the device or with the application, or even predicting potential issues with the device, or even new business opportunities. So these are some of the advantages of digital products and services. Um, Number one, digitized products are dynamic. So they contain both the hardware, the software, and the cloud services component, and they can be upgraded via network connections and even remotely. However, classical industrial products, as you know, they are static, so you can only change them to a limited extent. The second one is digital products capture and submit their own state. So the provider can remotely determine whether the product is still functional and even trigger where appropriate maintenance or repairs. So remember the telemetry data. The third one is digital products enable network effects. So an increase in the number of digitized products increase the incentive for providers for add-on services and complementary skills. So this is also the reason why we have uh, ecosystems for certain vendors, like for example the ecosystem of Apple. And then lastly, digital products and services become part of an IS or information system, so which accelerates the learning and knowledge processes across all products. So the principles of service dominant design. The service dominant or SD logic, this is a fundamental service centered approach and to some extent opposite to the traditional good centered paradigm for large parts of the traditional business. So the principal idea of the service dominant logic is that all economic exchanges can be defined as service to service exchanges, considering all associated real or digital products. The five axioms for defining service businesses. So the origin of service dominant logic was slightly extended through modifications and additional premises to a body of five axioms and 11 foundational premises. So these axioms include number one, that a service is the fundamental basis of exchange and deriving the indirect exchange as fundamental basis of exchange. Number two is that value is co-created by several actors, including the beneficiary, so for example, the customer, but also the service provider. Number three is the actors or resource integrators, but cannot deliver value by themselves, but can participate in the creation of value propositions. And then lastly, for the four and five, value is always determined by the beneficiary, and value co-creation is coordinated through actor-generated institutions and institutional arrangements. There are also these four design principles for business model-based management methods. So these design principles not only apply to capture the general guideline or guidance and methods for designing digital services and products, but they also illustrate their organizational implications. it's a little bit wordy. The slide is a little bit busy, but the first principle, this defines the proactive base for an ecosystem-oriented management by positioning the orchestration tasks for specific actors in a service ecosystem, defining an organization's role as focal orchestrator in the service ecosystem, and for sharing the risks, costs, and revenues among multiple actors. The second principle defines responsibilities for using digital infrastructures for decoupling information assets from products and facilitate product exchange, and for driving value creation through digital channels. And then the third principle, so this postulate the mobilization of operant resources like knowledge and capabilities, which are the fundamental source of strategic benefit, and further uncovering and utilizing internal knowledge. And then lastly, the fourth principle, this principle demands for customer involvement to reflect on co-creation through customer journey as dynamic interaction, and for recalibrating service bundles to optimize customers' experience. All right. So the theoretical principles for the design of a digital infrastructure. So these theoretical principles include, number one, the structural integrity. So the structural integrity of the digital infrastructure. This is the fundamental basis for control and stability. The elasticity, so the elasticity of a digital infrastructure supports autonomy and change. The ambidexterity, of the digital infrastructure is the basis for reconciling integrity and elasticity, seeking a balance between the structural integrity and the elasticity. And then for the connectivity, the connectivity base is the fundamental mechanism of the structural integrity of the digital infrastructure. And the generativity, so this is the basic mechanism for elasticity of the infrastructure, generating new results, structures, and behaviors. And lastly, the modularity. So this is the basic mechanism of ambidexterity of the digital infrastructure to increase the separation and recombination of digital components. All right. So let's move on to the value-oriented architecture. In chapter 10, for the value-oriented architecture, the authors state that value is commonly associated with worth and aggregates potentially required categories like worth, importance, desirability, and usefulness. The concept of value is important in designing adequate digital services with their associated digital products, and to align their digital business models with value-oriented enterprise architectures. And from a financial perspective, the value of the integrated resources and the price defines the main parts of the monetary worth. In this slide, the value and service perspective of service dominant logic, the authors present their view of an integrated value perspective combined with a service perspective. So the starting point is the model of the digital strategy. So this gives modeling direction and sets the base and the value-oriented framing for the business definition models. And with the model, or with the business model canvas, the one in the left, and the value proposition canvas, so the one in the middle. So having the base models for a value-oriented digital business, these are then mapped, map these base service and product models to a digital business operating model. So the one in the right. So an operating model This defines the necessary level of business integration and standardization for delivering service and products to customers. And then from the value perspective of the business model canvas results suitable mappings to the enterprise architecture value models with Archivate. So the ones in the left. And then yeah, finally the authors set the frame for the systematic definition of digital services and associated products by modeling digital services and product compositions following related composite patterns. So the value proposition. So the value proposition provides value through elements such as newness, performance, customization, getting the job done, design, among others. The value proposition may contain demanded or supposed business requirement, which can be related to qualitative and quantitative descriptions. The value canvas extends the business model canvas to conceptualize and exactly define digital services and products for customers. And the value proposition from the business model canvas is projected to the value proposition canvas and divided into three perspectives as products and services, creators of profit, and painkillers. The digital enterprise architecture. So the digital enterprise architecture reference cube, this provides an architectural reference model for bottom-up integrating dynamically composed microgranular architecture models. So this model, the DEA reference cube, today provides a total of 10 integral architectural domains for a holistic architectural classification model, which is well aligned to embed all microgranular architectures for different digital services and products. So these 10 integral architectural domains are the ones that you can see in the cube. Digitalization promotes massively distributed systems, which are based on the development of IT systems with many rather small and distributed structures like the Internet of Things, mobile systems, cyber physical systems, and among others. So for the Internet of Things, the IoT connects a large number of physical devices to each other using wireless data communication and interaction based on the Internet as a global communication environment. And this supports smart products as well as their production enables enterprises to create customer-oriented products in a flexible manner. The microservices and microservices architectures, or MSA, microservices is considered to be an important enabler for the digital enterprise and the digital transformation. Microservices addresses a fundamental use case for microgranular architectures, which are developed and operated in an open world. So the open world approach is a bottom-up tailored digital operating model, which changes the perspective of a classical top-down oriented enterprise architecture. And then lastly, microservices should be designed to be self-contained by integrating with specific needed platform and infrastructure elements. So one example is the practice of DevOps. So in DevOps, microservices support processes of the CI/CD, the continuous integration and continuous development. And microservices should also naturally support resiliency and scalability in both cloud and on-premise environments. Architecture governance. So the architecture governance defines the base for well-aligned management practices through specifying management activities: plan, define, enable, measure, and control. And architecture governance for digital transformation changes some of the fundamental laws of traditional governance models to be able to manage and openly integrate a plenty of diverse microgranular structures like the IoT or microservices. To effectively support architecture managers for navigation, interaction, and decision support during knowledge-intensive management activities in a complex structural space, the authors adopted the idea of a decision support system, or a DSS, which gives the idea of managing decisions by navigating using what they call an enterprise architecture cockpit. So a cockpit, this represents a facility or a device via which multiple viewpoints on the system under consideration can be consulted simultaneously. So each stakeholder who attends a cockpit meeting can utilize a viewpoint that displays relevant information. So for the conclusion, number one, from the fundamental research question at the very start of the presentation, the authors first set the context proceeding from digital transformation to a systematic value-oriented digital product and service modeling according the service dominant logic, and to support the dynamics of digital transformation with flexible software and systems compositions, the authors leveraged an adaptive architecture approach for open world integrations of globally accessed systems and services with their local architecture models. And from there, the strength of the research results from the novel approach of integrating a digital strategy with digital business operating models for architecting flexible compositions of digital products and services. And also, the author suggests that for future research, future researchers will cover mechanisms for flexible and adaptable integration of digital architectures. The authors even suggest that they are working on to extend human-controlled dashboard-based decision-making by AI-based intelligent systems for decision support. And yeah, that concludes Chapter 10, Architecting Digital Products and Services.